Director, Mr. Sriraj Shah. Sriraj is founding member of NetSquare. The company has a strong security research and software development capability. NetSquare has been instrumental in developing and export security components to well-known companies in security arena like Milestone and NT Objectives. He leads research and development arm of NetSquare. He has over 5 years of experience with system security architecture, system administration, network architecture, web application development, security consulting, and has performed network penetration testing and application evaluation exercises for many significant companies in the IT arena. In the past, Sriraj worked at Chase Bank and IBM in the area of web security. Sriraj graduated from Marist College with a master's in computer science and has a strong research background in computer networking, application development, and object-oriented programming. He received his graduate degree in computer engineering from Gujarat University and MBA from Nirma Institute of Management, India. Sriraj has also authored a book titled Web Hacking, Attacks and Defense, published by Edison Westley. Today he's going to talk about defending web applications, strategies, methods, and practices. In this presentation, he will mention or discuss about how web applications cannot be defended by firewall or any other security products alone. Web application defense strategies require secure coding at application level. And the people behind it have to know application and protecting them by human intelligence. Knowing your application can lead to your web assets in logical way. Profiling web assets provides better picture of various possible threats. Knowing entire attack set greatly helps in designing and implementing defense strategies. Various new design strategies are evolving in the area of secure web coding, implementing HTTP, security server extensions, and following secure practices. Without further delay, I'll now Mr. Sriraj.
Thank you. First of all, I would like to thank Delon for inviting me on this podium and on this Malaysia. This is my first visit in delivering my talk on defending web applications. Is it audible at the back? Okay. I would like to start with some of the eye-opening information which is published over the last 2 years. 95% of companies were hacked from web application and 5% of them were aware of them. This is recently published in FDA CSI 2002. Most popular attacks are against web server, incident.org. 3 out of 4 websites are vulnerable to attack. These are some of the Gartner's report recently published. 75% is hacks occurred at application level. Web application incident cost companies $320 billion USD just in 2001 only. Why so many attacks are happening to application level? To understand why, we have to understand 2 evolutions. Number 1, the evolution at an infrastructure level, and number 2, the evolution at a web application level. Having a sound knowledge of these 2 evolutions, we can provide a better web application defense strategies. Some of the other areas where one can answer this why. Complex application requirement. Nowadays, like everything is centering around web and web application. So applications are becoming complex. Integrated approach, application should be accessed by mobile phone, application should be accessed by web, application should be accessed by browsers and so on. So applications are becoming complex and the entry point to the applications are increasingly high. Internet presence is the most important, and the reason behind the launching a web application is to share. So if you are sharing with your suppliers, your developers everywhere, you are bound to share the same application with the hackers. First, I will talk about the infrastructure evolution. This is like an infrastructure evolution phase 1, where there was internet presence, there was a corporate network connected to the internet using a router. You have your web mails, your www server running, database server running, intranet, etc. In the second phase of evolution, what happened is people came up with a DMZ, demilitarized zone, where they have segregated their internet presence and intranet by putting a router behind and hardening the DMZ zone. And in the third evolution, they came up with a firewall, VPN, and other devices to block the traffic which is coming from internet to their DMZ zones. Now, these three evolutions had a significant impact on defense posture of this evolution. In the first phase, what was happening is the traditional attacks like the brute force, RPC, buffer overflow, null sessions, all these buffer flow, were targeted to three levels. Number one is operating system level, where the popular attacks like IBC dollar, FTP, Sun RPC, etc. Number second was the services level, where we are talking about IIS web server, SMTP, POP, that is the services level, and then the application level where web or customized applications running on. In the first evolution phase, all traditional attacks were open since you have access to all three levels, that is the operating system, services level, and application level. By putting a firewall, VPN, IDS, and auth server, what happened was these traditional attacks were blocked. These traditional attacks which were pointing to services level operating system were blocked. Today, if you have a secure box, you won't be able to find 135 or 139 open on say Windows box or 111 on a Sun box. People are smart enough, they have closed their ports which are unnecessarily open. So this, either by using a host-based firewall or a corporate firewall, they were able to block services level and operating system level traffic coming in. So the only opening which was left was the web application level or application level, where your web and customized applications run. Due to this, next generation attacks came into picture. These next generation attacks are like SQL injection, parameter tampering. These all attacks are based on your customized application, web application, or any other client server application developed for a corporate. At the same time, on the defense side, there is an evolution which is going on, which is focusing on services level and operating system level. Added defense are provided by the vendors like a Microsoft or a Sun or etc. In the phase of accounts, shares, patches, updates, logging, auditing. All this area is securing services level and operating system level. So there was tremendous trust and potential is applied for defending services and operating system level. Since application level is still open, application level is usually developed by a developer. So these next generation attacks are very much happening to application level. This is the reason why so many attacks are happening on application level. Moving to the same principle, if you follow, there is a network security at the arena, then there is a host security, and there is application level layer logic. Routers, firewall, and switches have blocked network security. They have provided a great defense at a network level. Operating system, runtime services and components, platform services and components are well guarded by services and OS level components, and they are well defended by host-based firewalls or other firewalls which block essentially 135, 139 or any other RPC level traffic. Now you have like your customers, suppliers, employees, partners, users, prospects coming to your application. Since the application layer which is exposed to your external world, it has the three core components: presentation logic, business logic, and data access logic as a traditional one. And you have a hacker coming to it on the same framework. So since application is open for a partner, your hacker can walk into the same application. Second evolution which we have to see is the evolution of a web application. How web application evolved in last 10 years, because that can be linked to your defense strategies. This is the most primitive state of web server, where web server used to serve just the HTML or HTML pages instead in 85. There was a web client, which is a browser. You have a DMZ zone created, you have a firewall, and you are serving the static pages. Essentially, with the static pages, you can't do anything. You just send a GET request, take whatever it comes. You can't do anything. In the second phase of evolution, people have a demand for sharing database, sharing corporate information, sharing other information. They came up with a scripted engine. Scripted engine like dynamic pages created by ASP, DHTML, HTML, PHI, PHP, CGI, etc. So this scripted engine piece is interact with the database, which is an internal or a corporate resources, serve the pages, it goes to HTML and send back to client. In a third phase of evolution, people have more complex requirement of application. They have come up with the web application servers. Web application servers like WebLogic, ColdFusion, WebSphere. These are the core web application servers which are meant to host application. They are not meant to host a simple web application. They are hosting a complex web application. In this evolution, what happened is the application server given a direct access to a database, and the database access to a scripted engine was cut at that point. One can look at that the application server hosted in a trusted domain. Another domain which is separate for a DMZ was created, and that trusted domain usually hosts an application server. Following evolution, people came up with the middle layer components like COM, beans, etc., which is directly talking with the application server. And now these middle layer components talk to the database. No other direct access to a database. We are talking about a complex application, complex web application like a banking application, traveling application, and such. The evolution which is happening right now, which is coming up with a host-based application server and integrated framework. The entire box is for the hosting the application. That is where ASP.NET or a J2EE application came into picture. This is the evolution. This is a phase right now where you have a .NET application running on a server. The entire objective of that box is to host an application. So this is the entire evolution which have taken place so far. With this knowledge, now we know that since application layer is open, you have application evolutions have already taken place. You have a significant amount of complex application running. With this, we should have application analysis framework. When we have an application, we are hosting application, we are providing a defense to application. What we need is a correct application analysis framework. To defining two methods, usually when you are providing an application defense, you have to have two methods which we usually follow. Number one is a black box method, where what we do is analyze application with an attacker perspective, seeing the web resources available to a common user, like just seeing a port 80 or 443. You are hosting a web application, you have hosted a box, now what access you have as a hacker is the 80 and 443. You won't have any other access. So do a first analysis with a black box approach, put a box in front, stay on a network and do your analysis on 80 and 443 only. The white box method, you are analyzing application with full knowledge and access to deployment setup, source code and other resources which are on the box. So essentially you own the box, do entire analysis with a white box approach and come up with a defense strategy. Some of the tools which we can follow is one is the black box. Black box tools are essentially a browser is a most essential tool. Achilles, Netcat, Teleport Pro, Black Widow, Sniffer, etc. This you can use when you are performing essentially a black box approach analysis. White box tools, customized source code analyzer, logic diagram, etc. Essentially human touch. To perform a white box analysis, you have to have a human touch. There are no essential tools out there which can do these kind of analysis. Since it's development, developer develop these kind of codes, you have to go ahead and do code review or a source code secure coding strategies on it. And above all, mind is the most powerful tool. Now we'll look at the web application analysis cycle. Web application analysis cycle can be divided into these 5 phases. You take a web application, first you do a deployment analysis. At this phase, we are very clear that we are talking about application running with a port 8443. You have your services level defended, well guarded. You have your OS level defended, well guarded. There is nothing. The external internet penetration is via 80 or 443. There is no other port is open. In this framework, first you have to analyze your deployment analysis. What kind of deployment analysis you have is what database server you are accessing, what application level server you are using, what web server you are using, what is your configuration file, etc. Second, you have to have your application analysis with the black box approach. This application analysis will lead to attack identification. Attack identification leads to asset to attacks mapping. So you define all your assets while doing application analysis. After defining assets, take each asset and come up with a relevant attack set for each, and then defense strategies with a white box approach. So this is a way you feedback system. It's a feedback system. You refine your web application according to it and come up with the right defense strategies for your application. What I'm going to do is I have created a small demo. So whatever we are going to talk with will correlate with this essential demo. I have a demo application which is running on the same box with a VMware. I have created application. It is running with 2000, running on IRS. It is a small DVD web store. Now this is where the VM session is created, and this is where this application is hosted. Application is like this. Essentially, there is a DVD for less. If you go to www.dvd4less.com, this is a small web application where it has all ingredients of web application. It's a standard web application. It has two components. One is a consumer. As an end user comes to your application, you have a nice catalog over here. You can add to a cart. Item get added. You can go back. You can click here and see detail of the page and such. You can come back. Here are the rebate coupons out there. So one can see there are rebates available. Then this is a rebate coupon it has. You select say 2 pieces of branded like Batman and so on. So this is done. Now you check out from the application. It will move you to SSL page. Verify a certificate. Okay. Enter your name over here. That's great. Yeah. Enter dummy card number over here. And expired date is 12/12. Say submit order. So you are submitting order. This is essentially how a web applications are hosted and run. So this will go for authentication to your vendor or your merchant, and application come up with a report that okay, order is placed, blah blah blah, etc. This is a one component. Usually, if you go on a web or if you host application, there are two components to it. One is the end user perspective you are tracking or end user clients, and another is a logging component. This part is essentially, if you read over here, it is for dealer, supplier, and administrator. This component is essentially a business-to-business application where you want to give access to bulk buyers or such kind of application where you have created administrator, you have created dealers, and dealers were provided their username, password, and such. So say I am a dealer. So I go to Raj, enter my password, and I say login. So I am logged in. I have my order status over here. So these are the orders which are already placed by me. I can go ahead and put a new order. Let's say ABC Musical. For that I am putting order. I am buying 100 copies of Finding Nemo, 100 copies of Lagan, and I say ship me fast, and I submit. So the order is now added. Here is the ABC Musical. If I want to see a detail page, I can go ahead and see detail over here, and so on. I can upload my order. say over here I select and upload my order. Say this is a sample order. So I upload. So it is uploaded, and now I can see these are the product ID and quantity which I have uploaded. So this is the typical application we are talking about, where you have authentication, you have a session, you have database running, you have SSL application, and everything. Every flavor is in this application. So essentially, this application I am going to take as a demo, and whatever we gather, we'll apply to this application to make our concepts clear. Moving next. First, as I said, one has to do a deployment analysis, a thorough deployment analysis strategy. So coming to deployment analysis, there are 4 components which are supposed to be guarded. First is the web server, second is the application server, third component is database, and finally administrator observations. So these are the 4 areas which one has to focus with. Attack set for each of this are like config, ACLs, permissions, extension checks, reverse proxy, and cross-site trace are essentially related with the web server. Tools, you have to do these kind of stuff on a manual observation, or you can write your own scripts or such and do these kind of stuff. There are no tools available which can say, I want to check a cross-site trace, then there are essentially no tool. You have to do certain analysis by on yourself. Defense plan, you can go ahead and do IIS lockdown if you are running with IIS or a Sun or anything. There are lockdown procedures which you can follow. Patches and updates. For application server, you have a mapping, servlet/GSP usage, integration, permissions, and web IAM. Similarly, it is a manual observation. For a database, there are attacks can be on database user password, role-based attacks, query, extended SP. These are some of the stuff which you have to be aware of. Tools are available. SQLsecurity.com has some of the tools. You have SQL audit tools. SQL scripts and manual hardening are the best defense plans for it. This is very interesting. Administrative observation. These are the sometimes you can find a lot of good files out of this. Backup files are left on the server. Hidden web path. You go ahead and say /debug or /log. You find a logs for that particular application. Directory enumeration. Sometimes sometimes directories are marked with a directory enumeration. So you can see entire directory listing on a page by which you can see hidden files and etc. Common files and configuration files. Essentially, you have to do this by manual observation and removing file permissions. One of the things is sometimes we have seen in the field that obfuscation is bad strategy. People come up with, they say like, nobody is going to figure out which application server I am running since it is a backend. Nobody is going to figure out which database server I am running since it is a backend. They come up with they go on and change and modify their server string. So it is running with IIS. They make it looks like Apache. So when you send a GET request or a HIT request and see what server you get, you will get it's Apache, and you say, oh, it's running with Apache. I don't want to apply. I don't want to attack with the IIS. But obfuscation is a bad strategy. I will show you a tool. This tool is created by NetSquare. Essentially, this tool name is HTTP Print. This is a free tool. It is available on our website. What you have to do is you have to say www.dvdsfor.com. To start a run, it will go ahead and send 12 or 15 requests to identify which web server it is running with. It is independent of what server tag you receive. It analyzes only on responses which it takes and identify it is running with a Microsoft IIS 5.0 with 96.30 confidence level. It is actually running Microsoft IIS 5. Even you modify this Microsoft IIS.5.0 string by applying ISAP and you throw Apache, it will go identify that it is running with the Microsoft IIS. So if you try to obfuscate some way to your web server, it will identify. So essentially, these kind of tools hackers are having, and obfuscation won't work. There is a way by which you can identify what backend database is running. There is a way by sending certain requests you can figure out it is running with a WebSphere at the backend or it is running with WebLogic at the backend. There are mechanisms and strategies for it. So don't rely on any kind of obfuscation. Now, deployment attack points. Your firewall may have a reverse proxy, so I can connect. I open a netcat connection to your firewall and try to open a connection inside. So I give a GET request to your web server or a firewall and send internal GET with HTTP to your 10.0.0.1 or 10.0.0.2. If reverse proxy is allowed, I can start accessing internal web servers. On a web server, you have a configuration, permission, directory browsing, hidden path, and cross-site base, which are properties of web server. These attacks can follow on a web server. You have backup files, config files, and common files, which are essentially on a scripted engine. You have extended mapping, integration files, and web INF on application server, and then you have extended roles and XSPs on a database. Now we'll see one demo. Now see, this is my deployment environment. Right now I'm on my application level. I'm analyzing my deployment environment. Since I'm running with, say, IIS, first I will do IIS layout. This is another tool which we have created. I will do IIS layout and start enumerating what content I have on IIS. So here is the list of extensions which are going to be passed, or extensions which are going to be processed by IIS. I have .hpw, .ida, idq, .asp, .cr, etc. If I have a resource with this extension and I'm throwing it out before it goes to a client, I will process it. Then I have, these are the filters, or these are the ISAPs which are loaded on IIS. So you should know what ISAPs are loaded, since ISAPs are pretty vulnerable to buffer overflow and such. So if these ISAPs are not needed, just remove them. And finally, interestingly, here is the directory structure of my application, and I know that A and N over here are stand for anonymous and NTLM authentication. So these resources guarded with anonymous or NTLM authentication. It has a read, write, execute, script, and data browsing permission. So essentially, if you have a directory where you are just serving HTML pages or static pages, you should have just read access on it. You should not have any DB access or data browsing, directory browsing access. If you have directory browsing access and you forget your default .asp or index.html page, then entire directory will be shown on a browser, and people start accessing all the content of that particular directory. So you can go ahead and add these permissions to your web server. I will take this output of this particular tool and I can feed to another tool which is say deploy, scan deploy. Scan deploy, I'm giving my web directory essentially. Now it has analyzed and it came up with the result that these 15 files like catalog.asp.bag, pool.txt, pool1.txt, dbback.sql. So I have like a .sql file available to share, header.incn. So these 15 files have an extension which are not parsed by IIS. So these files will go as it is to your final client. So if I'm an attacker coming to your site and make a catalog.asp.bag request, I will get the ASP code from your site. If I'm an attacker and somehow I come to know that there is a db underscore setup, and there is a db underscore setup, I make a few guesses and dbback.sql. So I will get your entire SQL query. So essentially these files should be removed from your deployment environment. These are useless files and these files should be removed. Like INC files are there which are go straight into ASCII, converted into your ASCII file. Right. Essentially you have no file which is required, go is done. So with this, suppose say deployment analysis or deployment framework or deployment strategy is taken care of. Now we move to application analysis. To perform application analysis, first you have to do is, as I said, first you have to do with a certain analysis with a black box approach. First is gathering application information with black box approach. Crawl application using tools like Teleport Pro, Black Widow, etc. There are certain tools available which go on with a black box approach. You just give a port 80 and a host name. It will go and crawl entire website and come up with what resources you have. These resources are essentially assets. These assets are exposed to your end client or exposed with a security risk. So I'll show you a small demo of say Teleport Pro. On a Teleport Pro, I say project, starting a new project, www.dvds for flash.com, and I run this tool. I just start and give so it will start sending HTTP requests and starting to build entire tree, what resources and what resources are available. So it came up with the 44 files. It retrieved 44 files. These 44 files can be retrieved by anyone. It can be retrieved by a hacker or your prospect or your consumer. So essentially, this is a tree. You have got /catalog.asp, you have /debate.asp, order.default.asp, and such. So this is a way you can have an entire tree created. At the same time, if you go over here, it has downloaded all the files on a local machine. So it has captured all the files. This Teleport Pro just sent a GET request. Whatever response comes to write to a local file. So with this, you know what resources out there, and these are the resources, and you have all HTML code for that resource. Essentially, you are doing a black box approach. So you are sitting on the other side and analyzing the application. You are not on the box. This what you are seeing is what an hacker can see. Now, there is another tool which is created by us, which do little more analysis on it. So if I give, see, this is a tool called Web Robot. Essentially, this is a crawler with some intelligence. So what we do is we give Web Robot host it will start crawling each site and do certain checks on it. So it has crawled the entire application, and now it came up with the findings that say slash is giving me a C for a comment. So this essential page has a comment on it. It has a cookie. The slash has given me a cookie. Slash has a form on it, and a slash has a script on it. So essentially, with this, what I have is this is a resource, and what is on this particular resource, or this is my asset, and what all assets lying on this particular asset. So if you move to the next slide, I will show you. So this is the kind of analysis one has to do. One has to come up with the entire asset profile. So you have your found on slash. So if an attacker comes to your site, what it will find on a slash? It will find one form, one cookie. Slash start.asp as a path, like include has a path. Similarly, catalog.asp has email address on it. Detail ASP has form and a query string. This is interesting. Slash order app slash default.asp login equal to yes has a form on it. It has a cookie on it. It has an auth on it and a query string on it. Essentially, when we are talking about auth means like if that particular resource is locked by basic authentication and DLM authentication, digest authentication, or form-based authentication. So form-based authentication, you go to Yahoo or mail.yahoo.com, you get a form-based authentication where you apply your login and username and password. So this entire map will give you what assets lying on your website, on your web application. So you have, this is one phase of analysis over. With an attacker perspective, you are very clear about your profile, very clear about your assets and what assets are lying on your machine. Now, each web application assets which we have talked about, each identified attribute can have vulnerability. One. Number two, vulnerability can be exploited by a hacker. These form can have vulnerability by injecting something in a form can impact your database and such. Forms and query string are major sources of exploitation. Other parameters like cookies, scripts, client-side Java, VB, etc., and a path info include CGI bins, servlet, exposed to a business level risk. With this, we'll move to analyzing impact trail of each of these assets or each of these attributes. Client-side processing, web client can have an impact on a parameter processing. if you have a form or query, it can go across your entire framework. It will have impact on a web server, it will have impact on a scripted engine, it will have impact on application server, middle layer components will impact, and at the end, query processing will go to a database. So this is essentially an impact trail. If you are sending a GET request, get/account.asp will have an impact, host will impact on a web server, account.asp will access scripted engine resources, ID is equal to file, ID is defined in a variable form into application server, and the file will go ahead and take access from a database. Similarly, post request has the same impact. Looking at impact trail of the model, comment and email. These comments and emails sometimes enumerate a lot of information, like this ahref mail to admin@example.com. Now you know there is an admin user, so if this information is not required, remove from your web application. If you have an admin user, users are defined, and you have locked certain resources with NTLM or basic authentication, person can use this as a brute force parameter. Code in db.inc change blah 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 by John. So these kind of small comments you will find on all applications. If you today you start crawling certain applications, you will find getting these kind of information. This small bit of information can have a significant impact on your security posture of your web application. Moving to impact trail for applet and object. Applet and object has a capability which runs on a client-side processing, which can create a hazard for a client, and at the same time certain data processing engine. Usually we have seen applet and object have no impact on application layer or a database layer if it is used on a presentation layer only. Their impact trail applet is retrieved from a scripted engine or a web server, and class ID is usually associated with object. Impact trail of cookie and authentication. This is very interesting. Cookie has, as a client-side session, essentially cookie get used for establishing a client-side session. You have a session management which is done by a scripted web engine over here. You have a session decisions. Based on session variables, certain decisions get taken at application level, and based on this, certain database access piece goes and transport layer state. Essentially, cookies are going back and forth between a client and a browser, a client and a server, so that has a transport layer impact. If you are getting these kind of requests, say HTTP 1.0, 200 OK set cookie, the set cookie will impact as on a web client. This name of the cookie will set on a web client, value will be given by a scripted engine. Sometimes you see application level cookies. Like this is a session cookie generated, but if usually you send a request to Hotmail or anywhere, you will see this kind of more cookies like a CID or certain numbers were thrown by application. These cookies are usually generated by application server. So it is a part of your application logic. Maybe it is impacting the business logic or a data access logic. But essentially this cookie is not set by a web server. This cookie is set by your application developer or your developer, which is sending this cookie back and forth to make some decisions. So this is essentially a cookie trail. Similarly, impact trail or authentication has impact on essentially ACLs. You take certain decision based on a session, or you take certain decision based on a certain value. So on base, you define your access control rights on your scripted engine or on your application server, and ACL based decision you take on it. This authentication has access to a data access or database and other parts. If you have a form based, then essentially it will impact your application level. And if you are NTLM, basic, digest, etc., then it will be on a web server level. Based on this information, now we come up with like a form has impact on presentation, business, and data access. Query string has impact on presentation and business. Comment has some certain impact on a presentation, email, and such. So essentially, by mapping this information, you can see what is significant and what is very important for you, depending on which kind of application you have designed. Having this, we'll move next to attack and asset. So now I have listed certain attacks. These are the some list of attacks. There are many more attacks. Attacks like input validation, authorization, parameter tampering, authentication, brute force, session management, SQL manipulation, file operations, information leakage, error and exception, client-side manipulation, Java decompiler, cryptography, buffer overflow, remote command execution. This list of attacks has these list of attacks can be performed on these assets. So we know that if you have a form and if you have a query string, one can perform input validation on it. If you have a form and if you have a query string, one can do authorization attacks on it. If you have a form, if you have a cookie, if you have a script, if you have a query string, one can perform a parameter template. So your picture is now clear. You have an entire list of resources. Each resources or what kind of assets are there. So you know this has a query string, this is a form, etc., etc. And on this, now you know that these kind of attacks can happen. So you have your asset, and you have for each asset you have your attack. Now we'll go deep into each of these attacks. First, I have just bundled all attack list into one component. So like input validation, authorization, and parameter tampering is a one kind of attack. Severity and damages for each one of them: access to internal information, unauthorized access to content, unnecessary character injection to application layer, forcing application errors, bypassing ACL rules, breaking flow of application and logic. So this is a severe damage. These attacks can cause a severe damage to application. Input validation attack can happen on your web server, scripted engine, or application servers. It can come through forms and query strings. Authorization usually happens on your application level or application servers, and parameter tampering has an impact on your application servers and database. Now we'll see a demo. Okay, over here, I'm on a say catalog. Now usually like this is a form which is sending a request. What if I go ahead and do -1? So essentially at application level, quantity should not be accepted as -1. Now if it get accepted, what will happen is I will deduct by 14.99. So essentially charging me 14.99, I will charge a credit card company to get 14.99. So this is application layer bug. You can't blame these kind of bugs on a vendor or your web server. This is your own bugs. Similarly, what if I go ahead and inject say percentage sign? If it is not taken care of, it throw me off the error, which is enumerating type mismatch, string percentage. Wow. So something is going on. I started enumerating information on your application. Now I know, okay, this error is VBScript runtime error. So I can have my back of the mind and attacker start working on making a attack stack relevant with these information. Next, say I go to these called parameter tampering, input validation kind of stuff. So these are the mixed of both of them. I say login. I log in as Sriraj. So now I'm logged in. Now I go to order status and I click here. I see detail. With this, I see a query string with 379 on it. So I say, okay, 379, and then I go back and say 380, and so it makes sense. Like logically, it is increasing. So I go ahead and say, instead of 381, I go for 378. What will happen? I got an error. Okay. I go ahead and do a 386. Okay, still my order. I log in as a John, is another user. I log in and go to order status. Okay, so 383, which is of John's order. Now instead of 383, John applied 381. Okay, now you can see my order. So this is essentially a parameter tampering by which you are accessing unauthorized resources. John is not supposed to see Sriraj's order, or any other person who is not supposed to see my order. So essentially this is an application level bug which gives unauthorized access or access to resources which are not authorized by this particular person. So this is a way you can start traversing and enumerating a lot of information for other clients and such. You have a same database where you have 100 clients, so you don't know like how one client will use other clients' information and such. So this attack set essentially dealing with parameter tampering, input validation, and authorization. Moving next, what kind of defense you can provide to guard this kind of attacks? Number one, you have to have a filter one between a web server and a web client. You have to have a logical filtering of characters, information coming between your scripted engine and application server. And you can provide a better defense by at the endpoint where a database. So another way, you can filter all the incoming requests in this fashion. Added application level ACL to combat authorization. This 381, 382, 383 can be locked. These numbers can be locked with the user, and if user try to access another number, then it should be locked. So essentially, you can provide ACL level defense to it. Tight variable control to combat tampering, parameter tampering. So some of the other defense strategies you can apply is the filtering content using secure regex components. You can use a regular expression component. Each incoming request or each incoming parameter, you are taking a form or you are taking any value, you can, first of all, you can throw that to a regex pattern matching. If it bypasses it, if it passes it, then go ahead and process essentially these resources or these numbers. XMP level defense, which is coming up with the URL scan, you can do certain level of application defense, not all secure application, but certain level of application defense you can provide. Tight ACL on application layer, secure code review and analyzing variable trail. It is very important that if you really want to provide a better security to your application level, it is very important to have a code review done by a different person, not code review done by a developer, but another. Maybe in the same company, you can have like a two-person who provide a security related code review, in which you try to analyze whatever coming in, it has impact where which positions it is impacting. So this is the first variable taken by application. Down the line, what is the impact? So essentially, you have to have impact analysis with entire trail before launching black box testing. So these kind of tweaks you can do: apply percentage, less than sign, greater than sign, and such. Essentially on a black box. Next set of attacks which we are going to discuss is authentication, brute force, and session management. Essentially, I have gathered all this in one bundle. Severity and damages, unauthenticated access to resources, application layer user pass info may lead to a privilege escalation. Once you have certain access, you can go ahead and do a privilege escalation on each of them. Session hijacking and spoofing, well-known examples, well-known cases out there. Damage to critical information and database access. So this is one of the very severe attacks. When you are talking about authentication, session management, it is a very severe attack that can happen on this level. Authentication, essentially, if it is a form-based authentication, it will be on an application server. Brute force attack usually done on application server. Via application server can do a brute forcing on your database. Forms, auth pages, and cookie can be used for these kind of attacks. Session management attacks usually happen on a session management. You have a transport layer in between. Someone can steal your session if the session is not established on SSL and come up with pretending like you. So essentially, these are session management attacks. Before we go to defense strategy, I would like to demonstrate some part of it. I just log out. First of all, what I will do is, there is a tool called Achilles, if you have heard of. It is a small tool like this. Essentially what this tool does is, it will sit between server and a client. Whatever request you are sending from a browser, it will intercept that request before it's sent to a client. You can manipulate that request at that point and send it across. So I'm intercepting modes on for a client data, and I'm starting it on port 5000. So it is now started on port 5000. I go to my tools, HTTP and HTTPS request through this proxy. So I can see what browser is sending, and I can start manipulating it if required. So I'm saying okay. So now this is all set. Now if I say John, and I say login. So first login request will generate it, and login request will come to this tool. Now I know that I'm sending user as a John, pass as a John. This is a post request made, so I send across. So this is a request which was sent by server to me. It gave me a 302. And now at this point, very interesting, it sent me a cookie since I am authenticated. So it gave me two cookies. It gave me an ASP session cookie followed by CID is equal to 1004. So it gave me two cookies since I am authenticated, and I gave a send. So now this page essentially will come to browser. So now this is a front page with John Whitman with 1004 is looking at. Now I go on, say, order status for the John. So John's order status is going. Another interesting thing. You can see this cookie is coming back and forth. So essentially, John sends whatever request, it will send with that particular cookie. There are two cookies. One is the ASP session cookie, one is the application level. This CID cookie is generated by the source code. This CID cookie is not generated by application server or not generated by a web server. It is integrated part of your application. So I send it across. It came up with this page. I'm showing it over here. And now this page this is essentially a John's framework where John is whatever John can see over here. I send an order status now, once again. Now I'm a little disgruntled. John didn't get discount from the company and so on. So he's analyzing this application and trying to do something else. So instead of 1004, it will go ahead and do 1001 on the cookie of the value. At this point, this cookie seems very obvious that there is a number going on. On the field, we are seeing these cookies are generated with hex coded. Sometimes these cookies are generated with Unicode. Sometimes these cookies are generated with a big number, randomizing and such. But if there is a logic in this particular number, then one can reverse engineer that number and come up with as simple as 1001. So essentially, if it's hacked, you can just convert it and come up with this number. So I'm sending 1001 now. Oh, it comes with a response. Wow. Now I can say Shaz. So I enter as a John. By just manipulating the cookies, I can become Shiraj. So this is the way the entire session is hijacked. Entire database is hijacked. Everything is hijacked. Another interesting, sometimes these kind of application has got like you have administrator coming to the same application and sharing. You have client coming to the same application, dealers coming to the same application, and these numbers are bifurcated. So say 1,000 to 10,000 dealers, 10,000 to 20,000 admins, 20,000 to 30,000 this. So what I try is, someone will try say order status again. On order status 1004, instead of that, what if I start increasing number of first digit? So I go on a 2000 and I go 2001 and I send it across. Now you can see, actually I become an admin on this box. I admin for this particular application. Now I can change discounts over here. This discount changing field was not there. Essentially, as a dealer, I cannot change discount, but now I can change discount since I become an admin for this particular store. So now I can process. I start processing applications. Oh, your order is sent. I can send like 100% discount and such, and I go ahead and do updates. So these updates, I will send each update with the particular cookie value which is associated with the admin. So I send update 2001, 100% discount. I send it across and modify with the 2001. So I'm sending with the admin privileges. Okay. 380 has been updated. Wow. Order status. Okay. So now if I log out, I will close this essentially. Come come with different options. Remove the LAN settings. And I become a Sriraj. And see order status. Oh, wow, I have 100% discount over here. Here we go. So essentially this way one can hijack entire session. This hijack, even this application running on SSL, person can do this because I haven't taken it from a transit. I have taken the legitimate data coming to my own machine and I started manipulating. So essentially this is a very severe threat to application. Back. The defense strategies for this, secure tunnel number one, tight session ID. Session ID should be, let session ID get generated by certain vendors. Don't try to generate your own session ID. Web IIS or WebLogic or these kind of web application servers are coming with the right logical huge login ID which cannot be guessed or which cannot be, it is very much randomized. Lower use of application level cookie. See, essentially, why to use application level cookie since you have a session cookie? Session cookie has its own strength since it is a random. On top of it, what you try to do is you try to take a decision by sending another cookie ID. Rather, what you should do is let the session build on a session variable. Use as many session variables you want to use to keep track, but keep one data, one session ID, and use all other numbers. So do not generate application level cookies. They are bad actually. They can be manipulated very easily. So do not use application cookie. Just take your decision based on session variables. Application layer account lockout. Suddenly I can start brute forcing your form page. So like if I come to know, like I apply username password for 4 times, 5 times, 6 times, 7 times, I know like okay this guy has no lockdown, so I will generate automated tool and start brute forcing your web application. So to provide this, what you can do is you can have a lockdown framework into application level, which is very often seen. Certain bank application has this kind of mechanism, but not all applications. Defense strategy, as we discussed, strong session ID should be generated, hard to guess and random in nature. Usage of session variable and not on application layer cookie and such. Application layer user password and lockout with strong password policy. Now moving to SQL manipulation. SQL manipulation has a severe damage. Direct database access may manipulate or damage database depending on role of application. One can get root or admin level access on the system. Database enumeration and disclosure of critical information. This SQL manipulation can happen via form or via query string. It attacks your application server and it attacks on your database. We'll go and do a demo of it. Certain attacks you have to do using known ID. So to do certain attacks, don't use IE. If you in IE you give .. it won't go to a server. So Mozilla or Netscape, these kind of attacks you can do. So suppose I go to catalog. I go to a detail page. Now on a detail page, I can see ID. So first of all, after looking ID, I will give a single code. Essentially, if I am a application developer or with a tackle framework, what I will see is if this is going to a database, by sending single code, it will terminate the query. So I will send that and wait for a response. Okay, I got this response. Microsoft OLEDB blah blah blah, ODBC driver blah blah blah, ODBC SQL server driver. Okay, now I know, right? I have hit SQL server which is running back end. So now instead of 1, what I will do is I will go use a chip trick 1 plus or plus 1 equal to 1. So this is always true. And then at the back I will give 2 dashes which will comment out rest of the SQL query. So essentially, if there is a query, what I will do is this part of a query will get executed. Whatever is rest will go away. So in this case, Now I can see all the products on the same page. So I have retrieved entire table. So if table has a 500 entries, I can see all the entries. So one equal to 1 is always true. So I know that there is a select query. This one is going to a select query. At the end of the select query, I will give or 1 equal to 1 and remove the rest of the query. So it goes into it and comes with the entire block of data. This attack won't end at this point. And an attacker will go on and do another attack, which is called, I will go %01. That way what I am doing is, I am essentially terminating that query. I am giving exec. It's a SQL command. I am calling master dot cmd xp underscore cmd shell plus single quote dir. I'm running a directory command, dir plus to c pub www / dir.txt and ending it. So essentially what this is doing is terminating the query. This is just my guess. I'm guessing that this server may be running with the SA privileges. This application may be running with the SA privileges or any other privilege which has access to a master database, which has XT command shell not disabled, which is a usually default. This is a default configuration. So I hit command. Got an error over here. So this command get executed. Now if I've redirected the output of this directory command to my inet pub www. So if this command is get executed well, I should have a file created called dir.txt over here. Blah. So with this, with admin privileges, using a web application, I was able to run a remote command on this particular machine just due to SQL injection. So you can imagine what significant impact has SQL error on your machine, on your application. Moving to a defense strategies for it. Input filtering, %01%, all this kind of junk characters should not ever enter into even a web server level, forget about application level or SQL level. Application layer filtering, before processing any variable, apply regex pattern to it. Secure database access control. It is very essential if you have a complex application running, you should have a separate secure database component, which every query should go through it. On a database that is falling on a deployment setup, application role-based access. You should not be running any application with asset privileges or any administrative privileges. You should create a role with a username and password. That role should create an application, and these roles should have limited access to the application. Tighter password and usage of passkeys. Web server level input filtering, application layer filtering type. This we have already. No direct select statement from presentation layer. Never. It's a bad way of programming. There is another good way by which you can provide a strong defense to your database is, number one, use the stored procedures. Don't straight away fire a select queries from a presentation layer. Make a stored procedure in your database. So stored procedure by default will not take any other character. It will throw an error to it. Number two, you can have parameterized queries where at ampersand or at you have to pass a parameter. So your query is designed in such a way that it won't take any other character in it. So this is what we have done with the SQL injection. Another interesting attack is the file operations. File access to a system level. These attacks can lead to read access out of web root, write access on a web root can lead to higher level of access and operating system level access. Usually what we have seen is if you go to many applications where you find a certain path or a file name in in your URL or in a post. Essentially what it is doing is it is taking that file, accessing that particular file from a OS and doing some operation and throwing to a client. So suppose I go to my application over here. I go to a rebate coupon, suppose. Now if you look at the structure of a rebate coupon, it is showing in the bottom when you open it. It is saying rebates.asp question mark LOC is equal to backhand.html. So I say rebates. So this is a common structure for a rebates.asp page, which is saying rebate.asp location or LOC certain HTML page. This you can find on many web applications. Now what if I just remove this, suppose? Okay, I got an error, file not found. So I say, okay, this HTML file is doing some operation. It is this rebate.asp is trying to access that file and throwing back. So instead of that, what I will do it over here is I will give // rebates.asp. I say read rebate.asp and I give it okay block. Go page source. You got the entire page source. You got the page source of ASP. You got unparsed ASP page. Now on this page you can see all what it is doing is creating an object called file system object and trying to access the file. I go on and enumerate. Okay, oh block. Here is another file dbinc. So I start with this information. Now I start enumerating a lot of information at application layer itself. So I go ahead and try to access that. // okay, wow. So now I have like, okay, it is a server is one time local host. It is running a server, SQL server on a local machine. Catalog is a database name. SA is a password. Root 30 is a password. So this way I start enumerating a lot of information. By having a small error, it can now making a huge difference as we go on a time frame. So this is due to a file operation. Another interesting error which we have observed on the field, I will show you. Suppose I have ordered this end card, I check out. Okay. Now I enter John, address blah blah blah, blah blah blah, state blah blah. Expired date. Well, I submit order. Now it has given me error. One orders 14301 already exists. Error on the CGI. These kind of errors you usually see. So I go back, reload a page. Same error. Once this order gets processed, I know that there is an order number, something 30990, and it is saying do not use back button or something. So what if I go back and submit order once again? This gives me error. Orders 3090 already exists. So this has these information leakage has given me an internal path that there is something called orders. So I'm curious where these orders are. So I go over here. And I give orders. Wow, these are the orders already placed, and it has a write operation. So there is something called a write operation happening from that CGI, and now I can start retrieving whatever orders are placed. It may have a credit card number, it may not have a credit card number, and so on. So these kind of errors can lead to a lot of information enumeration. Now I'm curious that someday where this number is coming, 14301 and such. So what I will do is I will go back, I will reload this page. Sorry. I will go back, I will go to backlog, add to cart, checkout. And now I know that somehow after moving from this page onwards, I'm getting some number. So I go and do a page source on it. On a page source, I try to analyze this particular source and see over here hidden numbers. Order number 302. So I know like some kind of random number gets generated and passed from this page to onwards. So what I will do is I save this as a local page. Save page as. I will save this page as checkout.html. So this page is now locally saved. So I can manipulate. Essentially, I can now manipulate information on this particular page. You can go on over here. Take this checkout.html page, open it into, say, Ultra. Try to modify certain information. Over here, what I will do is hidden parameter. Okay. Here is the hidden parameter or random number generated, order number 2006. So what if I say create a ASP file, var.asp, suppose. So I know like I'm just making a guess, since it has created order number as a file name, it may create a var.asp as a file name. So I go ahead and save this particular page on a local. Now open this particular page. Do a page source on it. Now, this particular page, I give test, card number 11111, expiry date 2012. In the name field, for example, suppose what I will do is, I will try to inject ASP code in. Instead of a name, I will try to inject ASP page, and since the page is going to be created as .asp, so say I have tools. I have say get environment.asp page over here. You can inject GSP page, whatever kind of page this entire application is supporting. You can go ahead and cut this code, paste it over here. Problem with the I. Let's open the same page over here. essentially what you can do is, this part is not working right now. But what you can do is, actually let me try one. I'm again using Achilles over here, setting a proxy on it. Anyway, what I was explaining is like you can this way you can inject ASP page into your application and then call ASP page. Since input validation is not done, what content is coming up, so I can inject .asp in it. So essentially, if person can do that, then you can get a remote command execution on ASP itself. So this is one way. Other way is sometimes if you see this kind of pages. I log in over here as Sriraj. There is an upload order. Now upload order, if there is no extension check is made, I go on browse and say upload a malicious ASP code in it or a GSP code in it, which gets processed by application server or a web server. Get environment and upload. Now this is uploaded. This kind of code which I have already injected in it, which is saying read, write, and etc. Now I call this particular page since I know where it is lying. Wow. So this page is uploaded on a web server since upload feature was provided. And now I can start enumerating all the content. So this GET request, so this ASP page has processed the request and come up with whatever parameters were sent from from client to server, and I can have an entire profile of application server or a web server parameter. So these kind of file operations are very, very hazardous essentially. This can lead to a remote command execution. On the top of it, one can do a privilege escalation and become an admin on the box. This everything can happen only through a web application. We have not access to RPC level. We don't have any access to services level. To defend this kind of mechanism, you have a no write operating access. Never give a write access to any application or a web server. Either you go through a database. Never give a file access or a file write operation. No read operation out of web. Make sure that whatever content you are reading from with a file object should be on a web root, and tight file access on object. Defense strategy we have already talked about. Information leakage and error exception is another part where error exceptions are poorly handled. We come up with a lot of enumerated data. Info leak from a database, web server, or application server information get leaked. These information can be used later on for advanced level attacks. Error text control, tight error and exception handling, stack level information control, and such. So this is essentially a defense strategy for information leakage. Proper error handling, exceptional handling object. Essentially, if you are creating a complex web application, you should have an entire component created for exception handling. Similarly, for a client-side manipulation, the client-side attacks are a CSS, cross-site scripting. Essentially, for a cross-site scripting, no client-side validation. Never provide any client-side validation from a JavaScript or a VB script which get executed on a browser. Outgoing error text control input should not go as output. Sometimes you will see like I send one, that one comes back to me in a HTML format. So I am sending my name, my name is Shiraj, it will send me welcome Shiraj. So like at that point I can send a malicious JavaScript which get executed on a browser or maybe executed on another browser. That's where a CSS, the root of CSS lies. Proper error object. These are the different strategies we have already talked about. Some of the Java decompiler. If you have a Java applet created for your application level, what it can happen is one can download entire Java application. It will decompile it using a JAD or other tool. So never use these kind of tools or these kind of components which can be decompiled. If you are using objects which can be decompiled and such. Proper use of cryptography over cookies, which is highly recommended. For these kind of stuff, you have to have a secure coding standard to avoid buffer overflow, applet usage for application and presentation layer, and a better cryptography usage. This is one of the most severe attacks which we have seen on field is remote command execution. By application, if you have a remote command execution, you can do many things. It is a myth that one cannot get admin or root access from application layer. We usually feel like I'm scanning just port 80. How can person can get the entire box from it? There is a trick called one-way hacking. What we can do over here is okay, I've already logged on over here. I'm giving an upload order. I'm putting a page called cmd.ast. Upload this page. This page is uploaded. Over here I am now saying cmd.ast. Now here you can see there is a small web prompt. I would call a web prompt. This is a AST script which is uploaded. Now I can give a dir over here and say run. So now I can executing a remote command with iUser privileges. I have a iUser privilege. I don't have admin on this box, but I have iUser privileges and I can start running the command. Interestingly, you can see this is entirely one way. So I don't need a shell back. Essentially, if you have a firewall, behind a firewall you have your RPC or whatever open, you need sometimes firewall will block outgoing traffic, which is not a stateful firewall will block outgoing traffic. This is absolutely legitimate. There is no blocking. I am just one way doing all my operations. And I can, from this step onward, what I can do is I can load my privilege escalation tools for a Windows and try to become from iUser to try to become admin. Another interesting stuff which one can do is I can go on browse Sql Query. Yes. Uploading it. Now this is a small ASP return which is trying to access the database straight away, directly accessing the database using SQL driver or a JDBC driver or ODBC driver or whatever. So I know DBINC from DBINC, I know the information of this SQL user. So I say 127.0.0.1, username is SA, database name is say orders, password is connection string. I'm using, since I know like I can use a SQL server since the backend SQL server is running, and I give select star from users. So now with the SA privileges, I have started to run query on SQL server. Now it has come up with a user table, so I can start enumerating what tables are there in an application. Each table has what characteristics are there. All these things can be possible since I know SQL queries. So I enumerated this. I get a username, password, category, etc., etc. So this way, just a one way. I'm just doing a one way and now accessing all resources. At this point, what is happening is I'm accessing this box, but at the same time I start accessing other boxes which are falling on the same DMZ. So instead of 127.0.0.1, I start entering 10.0.0.1, 10.0.0.2, and try to capture entire range. And wherever is 143p is open, this query may go and work. So this is a severe remote command execution stuff one can do on this. Privilege escalation, and this is end with owning the system on web, only on HTTP, HTTPS. One can do these kind of operations. Finally, talking about secure coding and strategies, layers of validation. Number one, do not trust on inputs. Source code review at a presentation layer is very critical since you are looking for input validation and other critical bugs. Analyzing variable and input trails. Here I can give you a small demonstration of a source scan which I used to use. There is a tool called Scan SRC. What I do is use a scan source and give all my ASP or whatever component file where in which location it is lying. So it will make now it has analyzed all directory beneath www root and created a file called output. Now this output.txt, essentially there are certain patterns which are being captured, and it has come up with product ID is something where form ID, it is taken from ID called form. So essentially I know like these are the input points for my application. So this entire stuff is the input points. So I have an entire list of my input points on which I can do my source code review or my analysis on it. Essentially this same tool, what I can do is I can ask for plus or minus 3 lines. So I say, find the pattern, give me 3 lines above, 3 lines below. So this will give me that. So now from this I can see whether input validation is made or not. So this is a point where something bad is coming in, essentially. So form request.form and then ID variable is taken from HTTP request and start processing beneath. So essentially at this point I know, so I go ahead and catch a +5 or -5 lines and see what kind of operations are done on this particular part of the code. This tool can be advanced and one can go ahead and make entire trail of application. Like this is the ID is taken, at this point it is assigned to this variable. This variable has impact on this common component. This common component is accessing this data. So this is essentially these kind of a source code review one has to perform to make an entire code secure. Impact analysis with assumed input. Security function, this is very important. One has to have a dot like secure.include or secure.asp or secure.gsp kind of page or beneath component. What it does is provide security features to each of the inputs. So you can write a small regex function which will check that percentage should not come, and whatever input is coming, just apply that function, and if you get true, then go ahead and do the rest of the process. If it is false, just throw as an error. Session management and cookie coding. Be very careful with the session management and cookie, as I have already told. No hard-coded secrets. Never keep any hard-coded secret onto the code. No plain secrets in the code, memory, config files, or database. Just keep everything out of web. Don't keep anything in a web root. Common error object and powerful exception handling model. OS level exec call should be filtered. never ever make OS level calls from your application. Let it be filtered out. Message passing objects from presentation to business logic should be filtered. Array bound check, maximum minimum control to be provided. File access path and decision should not be made based on a file name. So essentially, we take a decision based on a file name or extension. It should be based on a content. So like if you have a file.asp, you have to make sure that ASP file has just the ASCII content before you start doing any processing inside the code. So essentially, these kind of different strategies one can provide to do a hard coding or a secure coding. So that's pretty much it. Thank you very much for listening to me patiently. This is a book which has a lot of other information, and probably chapter 6 or 7 has an entire analysis on asset profiling, which I have already taught. So I'm open for questions.